I would like to pass it over to Payson and learn a little bit more about SkySafe use cases.
Hey, yeah, thank you. Thanks all for joining. My name is Payson Partridge. I work for SkySafe here in San Diego. So we are a drone detection company. We are drone detection as a software. So we provide comprehensive airspace analysis specifically for UAS. Largely, we work with areas where drones are not supposed to be flying. So whether that is airports, stadiums, correctional facilities, pretty much anywhere where recreational UAS drones should not be in the air. Our system allows for customers to detect, identify, track, and then analyze based on RF software. We are able to see these drones real time and get a historical track of where they've been, depending on multiple flights across wherever we see them. And that's all the sales aspect of it. My aspect and my team works primarily with uh, planning of deployments and then analysis post deployment. So specifically, we need to look in terms of what environment are we getting ourselves into, whether that is rural, where we're going to be dealing with terrain and any environmental factors, or in an urban environment where building and built structures are going to provide our complications. Um, so most of our work is done, behind the scenes in QGIS or similar software, where we can look at data and analyze it. But we have been using Felt heavily and extensively lately, specifically for the collaboration and communication internally. It's been so valuable to be able to share information in a live, collaborative environment. And there are a lot of people within the company who maybe don't have a background in working with geospatial software, and it has been very helpful. And it's such a easy user-friendly interface that um, they're able to import data, they're able to make notes, comments, and turn on and off layers and see exactly what they need to see, and we can get our point across, far easier than looking at a static image and trying to talk around that. Um, so that is me. That is what we do, and we can go ahead and kind of walk through a couple of use cases and show exactly how we use Felt to to plan and analyze some data. So Anna, if you have anything else, I can jump straight in sharing.
Yeah, perfect. Sounds good.
Awesome. All right. So let's see. I've got two specific use cases here that would be really cool to show. Let me just hide a bunch of things here. Perfect. All right. So first off, we'll go to Pittsburgh, and this is Pittsburgh Airport. This is a outline that was brought in of the actual airport property. Um, and I don't know if you've ever been to Pittsburgh Airport, but it's not really close to Pittsburgh itself. It's a good distance away, and it's a little bit more on the rural side. So when we come to a location such as this, it's really helpful to be able to know what we're trying to get ourselves into. So what we can do is we can go ahead and build out a bunch of contour lines and kind of get an idea of what we're going to be looking at, what we're going to be getting ourselves into. Um, and we can zoom in and see, okay, there's going to be a little bit of a high point here, a little bit of a ridge here. And if we are looking to, specifically have coverage over the entire airport, it's really important for us to know kind of what the general area is going to look like. So we can also, change the map here. And all right, well, there's, looks to be more buildings over this way and a little more rural farmland trees over this way, which makes sense. So having those different base maps can really help. And I just prefer the dark because I don't know. That's helps my eyes. So another great thing that we can do is bring in FAA data. So FAA data is pretty much the word of truth when it comes to where you can fly a drone and how high you can fly said drone. So we look here, and basically these are flight ceilings for recreational drones under the FAA. Anywhere it says 0 is you cannot fly above 0 meters, and or 0 feet in this case. Pretty much anywhere around airports, if there's any temporary flight restrictions, stadiums, any kind of important infrastructure usually allows no flight ceiling. Once you get out a little bit further here, it goes to 50 and then 200 and 400 eventually. So what we can do is we can actually export this data and bring it directly into Felt and look at it on our map here. And I'll just say that it's super easy to be able to bring this over, pretty much as easy as click and drag, download, click and drag, and it shows up, which is perfect. I've already got this loaded here. So we can see if we're looking at a location such as Pittsburgh, we can see here's all the zeros, here are all the 50, and we can go ahead and click on each one of these just to get more information. So what we would be looking at primarily is wherever it's a 0, and it's helpful to be able to turn on and off these specific layers. So obviously the entire outline of the airport is going to be within the 0, and a little bit of 50s coming in closer here. So if we were looking at this location, we would want to be able to probably do some flight tests prior to deployment to see what's in the area, and then post deployment just to make sure that everything is up and running, ship shape as we would want it to be. So this is where it's really helpful in the collaboration aspect of it, where we can work with the flight test team to determine these specific locations. And there's a little bit of secret sauce in there as to how exactly we would want to test it. But it's based off of distance from a certain location and altitude of where we can fly, right? Because we can't really take off anywhere in the 0 without special permission, which is going to take months to get. So we have to be able to go into the 50, 200, and 400 range. So to do so, what we would do is go ahead and create a couple circles here. Say we want to do a 5K circle from the center of the airport here. I can easily just create something with a specific radius of 5 kilometers. And let's go ahead and turn off that, right? So we can see that along this 5-kilometer radius here, we're not going to be able to do anything right here. But around this area, we do get into the 50s and the 200s. So on top of that, we can work with the flight team. They can come in here and specifically say, oh, actually, I really like this area, and test location 1, right? We can identify specific locations, and look at this just clips into this 50 zone here, and we got a country club. So let's go ahead and put another pin here and test location 2. So what we can do now is go ahead and share this with our flight test team. They can come in, post deployment, say they either did tests or not. They can make a note. Let's say they want to put a note up here and say it's really hilly. If I can spell right. They can put a note or even drop a comment in about test results. And they can tag me in here and have it specifically come right to me. So now we'll go ahead and get a notification that I was mentioned in a comment. I can come directly in here and reply, I don't know, something like this. And then we can have this internal dialogue specifically based on yeah, let's go ahead and post that. We can have our internal dialogue based on a completely spatial platform, which is super helpful and allows us to work, completely within a team and cross teams as well. We can bump this out. Let's say we want to go to 10 kilometers, and that gets us well into the 400 ranges. So this is something that's been super helpful in terms of test planning and making sure we kind of we know what the situation is when we get into it, and can reliably plan a test operation. Cool. Anyone? Well, we can just move on to the next one, and then we can come back for questions after that. And oh, another cool thing about these contours is you can go ahead and change all of the change the layout of this, where I know it's not technically correct to have different colors in your contour lines, but this does make it super easy to be able to show someone who might not exactly know how to read a topographic map to see, oh, this is, lighter areas are higher. There must be a little hilltop right here. You can zoom in, look at the specific elevations of it. So it's just been a super useful tool in terms of trying to figure out how to adequately and easily share knowledge and bring in a bunch of data from external sources. All right. So moving to our next, it doesn't want to go there. We want to go here. So moving to our next use case here is a more urban environment. So we were able to do a system testing here in Ottawa, which provided a really unique use case because Ottawa is obviously a big city. We have both, built urban environment right here, right by Parliament. But then it also does move off into a pretty, less built area, more suburban regions. And the terrain here it slants up kind of towards the south, obviously dropping down with the lowest being the river here. So when we would come to Ottawa prior to installation, we can go ahead and obviously buildings are going to be our biggest obstructions here. So we can pull in building data and then show this by different heights. So we can look and kind of see taller buildings are going to show up as red, and lighter buildings are going to show up as a lighter color, whether that's white or yellow or whatever you want to call that color. So obviously there's going to be a little bit higher buildings height here in the more downtown area, lowering to a more standard height in the suburban areas. So what we can do is we can go ahead and behind the scenes, we can run a bunch of viewshed and visual line of sight analyses, and that can kind of churns the computer for a little while, and it comes up with a theoretical grid pattern. And this theoretical grid provides a confidence level as to where we believe we'll be able to have high detection fidelity, and where our detection confidence is a little bit lower, where we might need to update our coverage or change the location of our system. So we can go ahead and behind the scenes on that, pull together a grid, and this was built in QGIS and easily just uploaded directly to Felt. So what this is showing is a theoretical grid of where we think we have really high detection confidence in the darker regions, and where detection confidence may be a little bit lower in the lighter regions. So stretching from 1 to 4 on the level gauge over here. So this was done behind the scenes, and then system deployed, and we were able to gather a good amount of data from it. And once we had a good couple months of data, able to pull all of that back in, and we can overlay all of the flight points that we can see into Felt. furthermore, we can go ahead and kind of do a little bit of sleuthing as to what altitude these flights are flying at. So this is altitude above ground level, and that's basically where they took off from to where the point and packet was received. How high was that? And that's really important because there's a certain level that drones are allowed to fly and a certain level that, above which it's really not legal to fly a drone. So this is kind of oriented by lighter colors are going to be lower to the ground, and darker colors are going to be a little bit higher. So this also shows retroactively that our coverage grid was, theoretically pretty accurate. There's, some pretty obvious blind spots where we would want to go in and update our coverage a little bit or tweak something to, get a little bit better idea of how we can properly cover the entire area with higher fidelity. So we use this in order to share with the deployment team, kind of say, hey, we need to look at, not circle. What am I doing? Wrong one. Marker. Say, hey, this area here, we should probably look at trying to figure out what we can do, something here, or maybe if our customer is looking for specific coverage in one of these areas, maybe looking at different options in order to provide them the coverage that is needed. And it's been really helpful to be able to look at all of these and, work across teams to be able to collaborate and talk about, how we would want to plan a rollout such as this. We can change all of these flights just to a single point if we don't really care about elevation and what altitude we're seeing them at. So we can just, drop them all in here and get an absolute blast of points. And for some people, that looks way too complicated. So we can build out a heat map and look at specifically where these are going to be when it's without looking at just a bunch of points. We can kind of see, obviously, there's a ton here, and we might be lacking a little bit here or a little obstructed in this general area because of any buildings. So what this allows us to do is really refine our process and make sure that we can provide the best coverage and give our customers exactly what they're looking for, and continually make our process more refined, smoother, and better for potential future deployments. Plus, Ottawa is like I said, a really cool example of how things really lined up, and it allowed us to make our process, go more smoothly in the future and streamlined. Yeah, so those were the main two things that I wanted to kind of share. It's a really cool platform, and I think the data from both of these places has been really helpful in trying to plan out these deployments and then retroactively look at bringing data back into the system and how we would want to move forward in the future. But
Awesome.
perfect. So that was all I had. We can go ahead and I can continue rambling on, or we can go ahead and answer some questions.
Thank you, Payson. Let's look if what kind of questions we have here on our map. If you have a question for Payson, I shared this link in the chat, so feel free to add more questions here. You can type. Everyone who's on this call can edit this map really easily. So, but yeah, we have a couple of questions here. First of all, I think someone is asking, what kind of tools did you use before starting to use Felt? I know that you mentioned QGIS, but I'm curious about your setup and how it worked for the team. And
Yeah.
what was the workflow was QGIS?
Yeah, so like I mentioned, we did use QGIS for a lot of the analyses. For when we would have to display anything or share anything or plan anything with a larger team, that was usually exporting into a static image and then talking over that static image, which just required, us to completely build something out and not be able to change it in real time. We also did use Google Earth quite a bit, which Google Earth is really great at some things and it's less great at other things, which proved to be a little bit of a hassle. So yeah, it was nice to be able to use an all-in-one software that really is comprehensive.
Awesome. Another question is about Felt API, if you use it or if it kind of matches your use case.
So
Um,
we currently don't use the Felt API. We use it primarily for how I was just showing, but I know that is a really really helpful tool as well.
Got it. And with FAA data, is it where can viewers find it if they want to also learn a little bit more about all the drone kind of regulations
Yeah, yeah. So
information?
that's all public data. You can go to the FAA's website and they have a specific area for UAS. And those maps you can kind of zoom around and see they have different layers. So the one that I had up was specific flight ceilings. They can also do completely no-fly zones. They have all the temporary flight restrictions. So say, for example, the government or a president is flying into a certain place, they're going to have a temporary flight restriction over that area or during a stadium. So all of that information is on the FAA's website, and you can go in there and download um, in any format you want. They also do have past reported incidents, which has been unique to look at as well. We You can go back and look at every reported drone incident with a pilot, which is a little terrifying at times, but really interesting to look through all that data.
Wow. Okay, thank you. I believe this question is from Damon, right? Would you like to ask it?
Sure. Yeah, of course, it's a very on-topic question for myself. But I noticed you using the contours and sort of doing a pseudo hypsometric tint with the color range. And we introduced support for like full raster visualization. And I wonder if you've tried doing that with just the raster itself, if you experimented with that at all.
So I have not in Felt specifically, but I have played around with trying to show it as just a raster in QGIS. I know you can import just full raster data sets. I haven't done that specifically in QGIS, but now that it's in here, I'll try and definitely try that out.
Awesome. And this question, not sure who asked it, but I am I think kind of following up on Damon's question, are there any layers in the data library that would aid your use case? We have this data library for anyone who's new to Felt where you can choose some of the pre-existing data sets. They're mostly focused on like um, global data sets and US data sets. They're not super local, but that's a good start when you're building a map. But I guess the question is for Payson to understand if any of the data library layers are relevant to airspace management.
For sure. We use the airports layer a lot. We can look at a lot of the airport and infrastructure layers. Those are really helpful to kind of get an idea of what's in the area because very often we'll have we'll have a coverage region that just so happens to include 4 or 5 other, areas of interest, right? So we could be covering an airport and, oh, that just so happens to be near a port, right? Or vice versa. There might be a smaller airport that would be interested in having that airspace awareness. So the airport layer is one that we use a lot. Another one that we use is more of the general background layers. So whether that is states or highways or whatnot, just to kind of build that background up and make it either just look more wholesome, or give a better idea of what we're looking at in the area, whether that is built urban infrastructure, whether it's a rural area, and just kind of giving a background knowledge as to what the general region is entails.
Awesome. Thank you so much, Payson. I want to open it to anyone who's in the audience, since we already went through this question, so you can just unmute yourself and ask Payson a question, or we also have Damon here who was working on our most recent raster launches. So if you have any questions about working with raster data or working with data in Felt in general, let's just go and yeah, let's just if you have a question, unmute yourself and you can ask. Okay. Well, giving it one last minute, and then we can wrap up. Okay, well, with that, I want to thank Payson for the presentation. That was just really helpful, and thank you, Damon, for helping us here. Everyone who registered for this event will get a recording. It will be also public on YouTube, so if some of your colleagues missed on this, you can share it. And we'll also share some of the resources that were mentioned. Thank you everyone for joining us today, and stay tuned for more events coming from Felt. Thank you, Payson. Thank you, Damon.
Yeah.
See you